Hi everyone! Today I want to take some time to remind you of some hopefully familiar formulas, and they are the distance and midpoint formulas that you see written on your note sheet there. Now they're already written down for you, so let's just go ahead and remember how we use these formulas. Question 1 asks us to find the distance between -2, 5 and 3, -1. So to find the distance, we're going to use this first formula here. The key to this formula is that you keep your y1 and your x2 in the same point, and your y1 and your x1 in the same point. So let's just say that this one here is my, oops, that should be an x, not a y. Say this is my x1, y1, and this is my x2, y2. So we keep those together. And then all you have to do is plug them in. Take your y2, which is -1, subtract your y1, which is 5, and square it. Then add your x2 minus your x1, which is negative, so you're subtracting a negative. We all know that when we subtract a negative, it's actually like adding those. I don't want to spend a lot of time going through the computation because really it's just plug and chug and you should all be able to do this. So go ahead and plug those in your calculator, leave them as a radical. I'll come back with the answer in a second. Okay, hopefully you already got this, but your answer should be the square root of 61. Now if you didn't get the same answer, go back and check your computations, or you can ask your teacher in class. Number 2, we want to find the midpoint of the segment joining -7, 1 and -2, 5. Okay, so we're finding midpoint, we're going to use this second formula here. Remember, if you're finding a midpoint, it's like finding a halfway point on that segment. That's why it's kind of like averaging your 2 points and dividing by 2. 1/2, halfway, makes sense. Okay, also your answer needs to be in a point form. So that's why you have these two kind of separate equations. Actually, maybe before I plug these in, I want to label my points here. Now, it doesn't matter which one you call your point 1 and point 2. So maybe I'll change up this time and call this x2, y2, and x1, y1. Okay, as long as you keep the points together, it doesn't matter how you label them. So plugging that into our formula, we have -7 plus -2, then you divide that by 2, and we have 1 plus 5 divided by 2. So again, I want you to practice computing these on your own. Go ahead and add them up, simplify if you can, and I'll come back with the answer. I hope you tried that on your own. If you did, you should have gotten this answer here. Again, if you did not get the same answer, just check your computations. I'm sure you can come up with the same thing I did. If not, ask your teacher in class tomorrow. Okay, so that's just a quick review of what you already know. But in this chapter, we're going to use these formulas and apply them to different situations. So the first applied situation we're going to go through is classifying triangles. Okay, so specifically, it draws this triangle for you and gives you that the vertices, and I'll just draw a triangle here, are A, which is at 4, 6. Keep in mind this isn't drawn to scale necessarily. B is at 6, 1. And C is at 1, 3. Now it wants to know if it's a scalene, isosceles, or equilateral triangle. In order to determine that, we need to know what these three words mean. So think back to our trig unit, or maybe to even geometry last year. Scalene means that all three sides are different. Isosceles means that you have two of the same side, but the third one's different. And equilateral means all the sides are the same length. So before we can determine which kind of triangle it is, we need to know the lengths of these sides. And length is really just a distance, so we can use our handy dandy formula up here to go ahead and calculate what each of those sides are. It doesn't really matter which side we calculate first. We're kind of going to have to guess and check, because who knows, maybe they will all be the same length, maybe none of them will be. So maybe I'll just start by calculating the length of AB. In order to do that, we got to figure out which one's y1, x1, all that good stuff. So maybe I'll call this x1, y1, and b, x2, y2. And then I can just plug them into my distance formula. So first I'll subtract my y's, which is 1 minus 6, and square them. Then I'll add the difference of my x's squared. So that's x2 minus x1 squared. Okay, and maybe I'll do the computation for this one, quickly at least. You can be doing it on your own as well, at your own pace. So in our first parenthesis, we have 1 minus 6, which is -5, squared. Our second parenthesis is 6 minus 4, which is 2 squared. Okay, and remember, anything squared is going to be positive, so we have positive 25 plus 4, which will give us then the square root of 29. That's my length of AB. But that only tells me the length here. We want to know, are there any that are the same? We've got to calculate the other sides then. Let's try AC. So AC, let's leave this as x1, y1. That means I'll call this x2, y2. Okay, so I'm going to take the difference of my y's, 3 minus 6, and square it. And I'll add the difference of my x's squared. So 1 minus 4 squared. I want everyone to go ahead and simplify this and see if it's the same as AB or not. I'll come back with the answer in a second. Okay, I hope you did that on your own. If you did, you should have gotten the square root of 18. Now notice AB and AC are not the same, so it automatically cannot be equilateral. It may be isosceles if BC is the same as AB or AC, or it could be scalene if all three of them are different. So I know I'm having you do a lot on your own, but I think you guys can handle it because you've been working with these formulas for a while. I want you to go ahead and actually set up the equation to calculate the length of BC, calculate it, and see what happens, and then we'll discuss it when we come back. Okay, check your work with mine. Again, I hope you're trying these on your own to make sure that you're okay with the computations. You should have gotten that BC has a length of a square root of 29. Now, notice that BC and AB have the same length. So think to yourself for a second, what does that mean in terms of what kind of triangle they are? Of course, I remember two sides of the same length is isosceles. So you solve the problem using your distance formula. Exciting, right? Number 4, write the equation for the perpendicular bisector of the line segment joining A and B. There's a lot of information, so let's kind of take apart what it's asking. First things first, you want to write the equation of a perpendicular bisector. Now another question we might want to ask is, what is a perpendicular bisector? First thing is it's just a line, but a special kind of line. Perpendicular means that it will meet another line at 90 degrees, and bisector means it cuts the other line that it meets in half. The most important thing though is that it's a line, so you're writing the equation of a line, and in order to do that, you either need a slope and a y-intercept, or you need a slope and a point, which is probably what we'll be using here since we're already given some points. Let's go back to this idea of a perpendicular bisector so we can figure out how we're going to write this equation of a line. So I know I have a line segment AB where A is -1, 4 and B is 5, 2. The perpendicular bisector to that would be a line that meets AB at its midpoint, so its halfway point, and it meets it at a 90-degree angle. So if we're writing the equation of this line, we're going to need the slope of the blue line. Now what do we know about the slope of the blue line compared to the slope of the red line? Hopefully you're remembering from Algebra 1 or from the beginning of the year that the slopes of perpendicular lines are opposite reciprocals. So in order to calculate that, we do need 2 points. So I guess we're going to have to calculate the slope of AB and then take the opposite reciprocal for our perpendicular bisector here. So this will be a nice little review of Algebra 1 and lines. To calculate the slope here, you need to take your rise over your run, which is really your change in y divided by your change in x, or y2 minus y1 divided by x2 minus x1. Okay, let's just call this point 1, this point 2. Go ahead and plug them in and calculate the slope. So we'll take our y's, subtract them, and our x's and subtract them as well. Watch your negatives and signs here. Okay, you're subtracting negative, that's really like adding. Adding there. So this becomes -2 over 6, which is really just simplified to -1/3. That's the slope of this red line here. Okay, but we want the equation for its perpendicular bisector. So the slope of the perpendicular line will be the opposite, so it'll be positive, and the reciprocal, which is 3 over 1, or just +3. Now that we have our slope here, we need to find a point that's going to be on this line so we can find the equation of a line. Now, what point do we know for sure is on this blue line? That's the midpoint of A and B. Okay, so we're also going to need to calculate that. and then we can plug it into our point slope form to find the equation of line. Okay, so remember, midpoint's just going to be a point where you kind of average the x's and average the y's, or take half of each of them. So our x's are -1 and 5 divided by 2, and our y's are 4 plus 2 divided by 2. So that simplified out gives us 4 halves and 6 halves, which we can then reduce to 2, 3. Okay, so that's a lot of work, but we're still not done, because remember, our end goal is to write an equation. So we have a point, we have a slope, we need to use point slope form. I'm just going to write down the formula. Hopefully you remember it. Otherwise, I'm not going to talk about it too much, but it's just your y minus your y1. Sorry, I'm creeping on to the next problem, but I'm running out of room. Equals your slope times your x minus your x1. Okay, where your y1 and x1 are your given point here. Okay, so I plug in my y, plug in my slope, and I plug in my x value. Okay, I want everyone to actually solve for the equation. Remember, all the equations are in y equals form. I'll come back with the answer in a second. Try this on your own though. With just a little bit of algebra, I got that the equation is y equals 3x minus 3. You can use the work I've written out to check yours if you didn't get the same thing. Otherwise, come with questions tomorrow. Last problem. Use the given distance, d equals the square root of 72, to solve for x. Now, I meant to write that this distance is the distance between these 2 points. I'll add that to your note sheet, but it doesn't say it here right now. So we need to plug in what we know to our distance formula since we're given a distance. Okay, this time our distance is solved for, so we can plug the square root of 72 in for d. And that's equal to, again, the square root of the difference of our y's squared plus the difference of our x squared. I always like to label my coordinates before I plug them in. Now, it doesn't matter that this is an x here. I'm still going to call this x1, y1 because it's in the y position, and this is x2, y2. So now I can plug those in and get 2 minus x, and then I square it, and I add the difference of my x's, 7 minus 0.5, and I square it. Now, since the x is under the radical here, we're going to have to do a couple different steps to get the x alone. So you're going to need to get rid of everything that's bothering the x. And the first thing that's bothering the x is this square root. So what undoes a square root? Think back to a couple chapters ago. And squares and square roots undo each other. So we'll have to square that. And if you do it to one side, you have to do it to the other, so you have to square both sides. If we do that, luckily these square roots cancel. It's actually going to simplify our lives a lot. Let's simplify that square root on the right as well. Then we're just left with what's under the radical. Just 2 minus x squared plus 7 minus 0.5 squared. And this 7 minus 0.5 is just some number. Okay, so you could actually simplify that part and square it. So let's go ahead and do that now. Okay, so 72 we're leaving. This 2 minus x we'll take care of in a second. 7 minus 0.5. Oops, that should have been a plus sign. 7 minus 0.5, you can plug in your calculator, or you're taking 7 and just taking a half away. So we're left with 6.5 squared. This should be a plus sign, like I said, not a minus. Sorry about that. Now, 6.5 squared, you can plug in your calculators at home, but since I'm a super smart math teacher, or just because I plugged it in without anybody looking, I know that this is 42.25 if I plug that in my calculator. Continuing to clean that up, we got to subtract this 42.25, going crazy here, from both sides. These will cancel out, and on the left we'll get 29.75, and on the right we're just left with that 2 minus x squared. Okay, almost there. So we still got to get rid of this square because it's bothering the x. I've already kind of said this, but in the reverse, so what undoes a square is a square root, opposite of what we did before. Okay, then these will cancel, and on the right we'll be left with 2 minus x. This we'll have to plug in our calculators. For the sake of time, I've already done this, and I got 5.45. Subtract 2 from both sides, you get 3.45 equals negative x. So then change of signs on both sides, or divide by -1. You get x is negative 3.45. Hope you enjoyed distance and midpoint formula. See you tomorrow.